Hello students, welcome. Previously, lesson 2, form 2, topic 4, we were dealing with methods of preparing soluble salts, and we have done the first method, which was action of dilute acids on metals. So today, lesson 3, we are going to proceed to the second method of preparing soluble salts, which is action of dilute acids on insoluble bases. Remember, when we are talking about solubility of bases, we said we have only sodium oxide and sodium hydroxide, potassium oxide and potassium hydroxide, and aqueous ammonia are the only soluble bases. The rest, they will be under the insoluble bases. Remember, we have also said magnesium oxide and magnesium hydroxide, calcium oxide and calcium hydroxide are slightly soluble bases. So we are going to start with the second method of preparing soluble salts, which is action of dilute acids on insoluble bases. So we're saying this method is best for preparing salts of less and moderately reactive metals. This include lead 2 nitrate, copper 2 sulfate, magnesium sulfate, magnesium chloride, calcium nitrate, and many others. So we're saying this method is suitable for preparing less reactive metals such as copper, lead, and moderately reactive metals like zinc, magnesium, iron, those ones. So we're saying note the following. Roman 1. This method is not suitable for making salts of potassium, sodium, and ammonium salts, as their bases are soluble, which are also known as alkalis. Number 2, we are saying lead 2 oxide cannot be reacted with dilute sulfuric acid and dilute hydrochloric acid, and the reason is due to the formation of insoluble lead 2 sulfate and lead 2 chloride respectively, which coats the metal oxide, that's lead 2 oxide, preventing further reactions from occurring. So Roman 3, we say calcium oxide cannot be reacted with dilute sulfuric acid, and this is due to the formation of insoluble calcium sulfate, which coats the calcium oxide, thereby preventing further reaction from occurring. So next, let us proceed to the general equation. We're having insoluble base reacting with dilute acid. What we are going to get is salt plus water. Remember, we are talking about neutralization reactions. So for us to know the endpoint, that's the determination of endpoint, we say we have 1 if unreacted metal oxide or metal hydroxide remains. So we proceed to the general procedure of preparing soluble salts using action of dilute acid on insoluble base. So the procedure will be similar to the first method. That's action of dilute acids on metals, but there's a slight change. That's the first part. We are saying here add excess metal oxide or metal hydroxide, that's our insoluble base, to warm dilute acid. Initially, we were not having the word warm. We're adding now. Roman 2, we filter to remove the unreacted metal oxide or metal hydroxide as a residue and salt solution as a filtrate. Then evaporate the filtrate to saturation and allow it to cool for crystals to form. Then we dry the crystals between filter papers if purity is required. So let's get an example. If I'm told prepare copper 2 nitrate, or I'm told to prepare copper 2 sulfate using copper 2 oxide, starting with copper 2 oxide, I'm given copper 2 oxide. How will I explain using this general procedure? I'll first of all start by saying add excess copper 2 oxide, that's my metal oxide, that's the one I'm given, to warm. So what is the acid am I going to use if I'm having salt of sulfates? That is sulfuric acid. So you say to warm dilute sulfuric acid. Don't forget the word warm. So Roman 2, filter to remove the unreacted copper 2 oxide, that's what I'm going to say, as a residue and copper 2 sulfate solution as a filtrate, because the salt I'm told to prepare is cobalto sulfate. Then these 2 points we are going to write the way they are. We say evaporate the filtrate to saturation and allow it to cool for crystals to form. Then last we say dry the crystals between the filter papers. Then we add the equation for the reaction to support our statements. Next, let's proceed to see points to note. Roman 1. We are saying the excess metal oxide or metal hydroxide is added to ensure or in order to completely react with the dilute acid. Roman 2. The acid is warmed to speed up the rate of the reaction. Then Roman 3. Filtration is carried out to remove the unreacted metal oxide or metal hydroxide. Let's go and see examples. Number 1, we are told describe how you will prepare sample crystals of cobalto sulfate starting with cobalto oxide. That's the one that we have explained. So we can say add excess cobalto oxide to warm dilute sulfuric acid. Then we do next, we are told filter to remove the unreacted cobalto oxide as a residue and cobalto sulfate solution as a filtrate. Then next, evaporate the filtrate to saturation and allow it to cool for crystals to form. We have explained the meaning of saturation in our previous class. Then lastly, you say dry the crystals between the filter papers. So how are we going to write the equation for the reaction? We are having cobalto oxide reacting with dilute sulfuric acid. What we are going to get is cobalto sulfate solution, which is our soluble salt plus water. So let's proceed to example 2. And example 2, we are told starting with copper metal, or you can be told starting with copper wire. Describe how you will prepare crystals of cobalto chloride. So here I'm given starting with copper metal, and the salt I'm told to prepare is cobalto chloride. So I cannot say add excess copper to dilute hydrochloric acid, because copper cannot react with dilute acid because copper is below hydrogen in the reactivity series. Therefore, it cannot displace hydrogen from the acid. So the first step, I have to convert this copper metal into a metal oxide. That's cobalto oxide. How will I do that? The first point, burn copper metal in air or in the air to obtain or to form cobalto oxide. Then that's the time I'm going to say add excess cobalto oxide to warm dilute hydrochloric acid, not sulfuric acid. We are going to have hydrochloric acid. Warm dilute hydrochloric acid. Then next, we are going to say filter to remove the unreacted cobalto oxide as a residue and cobalto chloride solution as a filtrate. This is cobalto chloride solution as a filtrate. Then next, we are going to say evaporate the filtrate to saturation and allow it to cool for crystals to form. Then lastly, dry the crystals between the filter papers. To write equations to support our statements, the first one, we are going to have 2 moles of copper metal solid reacting with 1 mole of oxygen gas. What we are going to get is 2 moles of cobalto oxide with solid. So the second equation is the cobalto oxide that we have obtained will be reacted with dilute 2 moles of hydrochloric acid, so that we get cobalto chloride solution, which is our soluble salt plus water. So we are going to proceed to example 3. We are told describe how you will prepare sample crystals of lead 2 nitrate starting with lead 2 oxide. So the procedure is the same. We are going to say add excess lead 2 oxide to warm dilute nitric 5 acid, because we are told to prepare lead 2 nitrate. So the salt is a nitrate, so the acid must be nitric 5 acid. So you say filter to remove the unreacted lead 2 oxide as the residue, and lead 2 nitrate solution as a filtrate. Then you say evaporate the filtrate to saturation, and allow it to cool for crystals to form. Then we have dry the crystals between the filter paper. Then lastly, we write the equation to support our statement. That means lead 2 oxide solid will be reacting with 2 moles of nitric 5 acid. We are going to get lead 2 nitrate solution plus water. So next, we are having 2 extended questions. Number 1, we are told starting with calcium oxide, describe how you will prepare sample crystals of calcium nitrate. Number 2, we are told why is the reaction between barium oxide and dilute sulfuric acid cannot be used to prepare a soluble salt. So kindly try to answer those 2 questions And that's the end of our class for today. Thank you for watching.